Before we talk about the laws of exponents, we need to first make sure we understand what exponents are and what they mean. So we've got three examples here, which is 4 to the power of 3, 2 to the power of 4, and 5 to the power of 3. So the 4 here, that is the whole number, is known as the base. And the 3 would be the exponent, or the power. Okay, in this case, is the power of 3. So what it means is an exponent actually just means how many times you have to multiply that number to itself. So in this case, 4 to the power of 3 is the same thing as saying 4 times 4 times 4. So you're multiplying 4 to itself 3 times, which is the same thing as 64. 2 to the power of 4 is the same thing as saying, okay, 2 times 2 times 2 times 2, which equals 16. We can do that with a calculator, of course. We could go, okay, 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. And 5 to the power of 3, again, is just telling us that we're multiplying 5 to itself 3 times. 5 times 5 times 5, which is the same thing as 125. Usually when we're dealing with exponents, we want to use a calculator because it's much easier. And you'll see a little button in your calculator, for the most part, that will have a little X and a little Y on top. And so this is what you want to use. X represents the base and the Y represents the power. So if you had to do 4 to the power of 3, you would click this number, you would click the 4, then you would hit this number right here, this little button in your calculator, and then you would plug in the 3, and it should give you 64. If you're doing 2 to the power of 4, you would hit 2 on your calculator, then you would click this number, plug in the 4, which is 2 to the power of 4, and your result should be 16, and so on. Now, exponents have laws, and today we're going to talk about the first law, which is the product of powers rule, which sounds very fancy, but it's a nice way to say the rules that we should follow when multiplying with exponents. That's really what the product of power rules mean. So we have a to the power of m times a to the power of n. We simply add the exponents. Now we're like talking about letters here. I'm like really confused. What does that mean? Well, let's look about numbers. So what that really means is that if we have 4 to the power of 2 times, notice that this is a multiplication rule. This only applies when we're multiplying with exponents, and 4 to the power of 3, as long as the base is the same when multiplying. So in this case, we have 4 to the power of 2 times 4 to the power of 3. Both have the same base. The base is 4. When that happens, we add the exponents before we solve it. So 3 plus 2 is 5. So this becomes 4 to the power of 5. And then we can solve that. And we can solve that, like I said, using our little button on the calculator that has the x to the power of y. And you hit 4 as our base, click the button, then plug in the 5, and you should get 1024, which of course is also the same thing as multiplying 4 to itself 5 times. In other words, 4 times 4 times 4 times 4 times 4. It's just the calculator does it much faster. Okay, so following that same rule, what happens if we have 2 to the power of 2 times 2 to the power of 2? So the first thing that we look at is what type of operation are we following? Oh, it's a multiplication. Great. We're multiplying numbers with exponents. So if we're multiplying numbers with exponents, we're going to apply the product of powers rule. And what that means is if the bases are the same, they must be the same. Remember that. We add the exponents. So we leave the base the way it is and we add the exponents. 2 plus 2 is 4. Now we can solve. So 2 to the power of 4 is 16. Okay, let's do another one. So what if we have 2 2 to the power of 2 times 2 to the power of 2 times 3 to the power of 2. Okay, so the product of powers rule tells us that the base must be the same. So we know that these two have the same base, so that's going to be 2 to the power of 4. Why? Because when the bases are the same, we add the exponents. So we've got a 2 here and a 2 here. 2 plus 2 is 4. So now we have 2 to the power of 4 times 3 to the power of 2. Now, why didn't we actually add this 2 to the other exponents? Well, because the base is not the same. So right here we have a 3, and right here we have two 2's. So the product of powers rule only applies when the base is the same. This is why we have 2 to the power of 4 now times 3 to the power of 2. So what this means is that we got to solve this individually. So 2 to the power of 4 is 16 times 3 to the power of 2 is 9. And now we can multiply these two together. And when we multiply those two together, we get 144. So just something to keep our minds on, that when we are applying the product of powers rule, we need to look at our bases, and we can only add the exponents where the bases are the same. Okay, let's do a couple of more examples. So what if we have 3 to the power of 2 times 3 to the power of 4 plus 2? Okay, so the product of powers rule tells us that we're looking first for a multiplication with exponents and the same base. So where do we have our multiplication? Our multiplication is right here. Do they have the same base? Yes, they have the same base. This is actually a 3. Looks like an 8. Okay. And do they have exponents? Yeah, they have exponents. So when we have the same base and it has exponents, what do? We add the exponents. So in this case, we maintain the same base, which is 3, and we add these two exponents, which is 4 plus 2 is 6. But we don't forget about the plus 2. That's still part of our equation. So we just bring it down with us, but we don't do anything with it because it's not part of this operation. So it's not a multiplication that has the same base with an exponent. We still bring it over. Okay, now we solve for the exponent, because if we recall on BEDMAS, okay, BEDMAS tells us that we look at exponents first and then we look at addition, right? So we got B for brackets, E for exponents, division, multiplication, addition, and subtraction. So E for exponent is first. So we've got our exponent, which is 3 to the power of 6, which is 729. And now we add our 2. So our total comes out to 731. Okay, let's do one final question. And so what if I have 2 to the power of 3 times 2 to the power of 2 times 4 to the power of 2? Okay, so once again, the product of powers rule tells us that we want to look at the same base. So these two have the same base. So we bring it down, we add the exponents on those two, which is 3 plus 2, which equals 5. And we still continue with our equation. We bring down our 4 to the power of 2. We just don't add the exponent to it because it doesn't have the same base. Okay, now we can solve for each of our exponents. What's 2 to the power of 5? 32 times 4 to the power of 2, which is 16. And then to finish this, we want to multiply these two together. 32 times 16, which gives us 512. So the key points to remember is the product of power rules looks at multiplication of numbers that have exponents. We need to make sure that the bases are the same, and we add the exponents and keep the base.